Look at the device in your hand. Trace the seam where the glass meets the metal. Every measurement, every cut is flawless. The same level of precision keeps a commercial jet engine from failing at 30,000 feet. The tolerances here are microscopic, measured in thousandths of an inch. Human muscle and bone cannot produce that kind of consistency. In fact, human hands haven't touched these core manufacturing processes for 40 years. A ghost logic has replaced the craftsman. It operates invisibly, driving the global industrial supply chain in total silence. This level of consistency suggests a system at work, a logic that exists behind the scenes of global production. To see how it functions, we have to find the specific entity that controls it. That trace leads to Fanuc, a secretive Japanese corporation that functions as the primary software layer for the manufacturing world. In the global robotics market, Fanuc controls roughly 1/5 of the entire industry. It is a massive institutional hegemon in factory automation. Despite that scale, the company remains relatively unknown. They operate in the foundational layers of industry, building the machines that build your machines. The true origin of this power is physically isolated, located in a remote complex at the base of Mount Fuji. Tracing the path from the object in your pocket back to this yellow city reveals how a single company's standards came to drive a massive portion of global manufacturing. In 1956, a young engineer named Dr. Seiuemon Inaba was working inside a Fujitsu laboratory. He was driven by a specific goal: total mechanical autonomy. At the time, industry was bottlenecked by human biology. Factories relied on the dexterity of workers, which meant every part was subject to the inherent friction and inconsistency of manual labor. Inaba proposed a bypass. If a machine could read coordinate data directly, it wouldn't need a human to guide its tools. This was the birth of numerical control. These early systems utilized an open-loop design. Factories fed perforated paper tape into mechanical readers, where each hole dictated a physical movement. But paper is fragile. If a tape tore or jammed, the machine stopped, and the logic of the assembly line failed. Punch tape proved that industrial machines could read. The physical medium, however, was too weak to support a global industrial standard. By the 1970s, Fanuc replaced paper tape and vacuum tubes with microprocessors. This created Computer Numerical Control, or CNC. The core of this system is the Machine Control Unit. It acts as a translator, sitting on the border between digital software and physical reality. The unit ingests digital G-code, pure mathematics, and calculates the exact electrical voltage required to drive a physical motor. That voltage is sent to a servo motor. The servo mimics the action of human muscle, but executes the movement in flawless, microscopic increments. Digital logic finally had the power to carve raw matter. Fanuc had built the definitive bridge between code and the physical world. In 1968, Fanuc introduced distributed numerical control. This allowed a single central computer to direct multiple separate machines simultaneously. Inaba had scaled his automation from individual workstations to an entire synchronized factory floor, creating a mechanical hive mind. The culmination of this architecture is their headquarters in Japan, where Fanuc designs and controls every layer of their own technology stack. They operate under the One Fanuc philosophy. The goal is extreme long-term reliability. These machines are engineered to run for decades without a human ever stepping in for maintenance. You can see the result of this engineering in a lights-out shift. The factory floor operates at full capacity in total darkness, because robots don't require lighting to see their work. In the dark, automated arms manufacture the parts for new automated arms. The precision we take for granted isn't the result of human hands anymore. It's the result of code, Fanuc's digital instructions, made manifest in steel.